Hello again and welcome back to Advent of Code 2025 and MIPS assembly for the PlayStation 2. We're up to day number 5, so let's have a look at it. It is called Cafeteria. And this time we are in the kitchen and we want to figure out which of the ingredients are fresh and which are spoiled. So we have an input that's split into two. We have a set of ranges, ingredient ID ranges, a blank line, and then a list of available ingredient IDs. Now these are fresh ID ranges, so any IDs that are within the range, inclusive, so 3 to 5 means that 3, 4, and 5 are all fresh. The ranges can overlap. The ID is fresh if it is in any range, okay? So any that are outside the ranges are spoiled. Ingredient ID 1 there. 1 is not within any of these ranges, so it's spoiled. 8 is not within these ranges, so it's spoiled. And 32 is not within ranges, so it's spoiled. Right. So we just want to count up how many IDs are fresh. In the whole system, I get a number there. And then for part 2, we want to, it says here, we want to work out how many IDs would be considered fresh. So you can't just sum up these ranges, because as you have overlapping, you know, these ranges overlapping, you'll overcount if you just sum up the ranges. So what we need to do is compress overlapping ranges and then sum them all up. Then once we sum them all up, we get a big number. So let's have a look at our code then. So let's see, we've got three bits of memory I'm going to be using this time. We've got this range list, which I unfortunately deleted. This range list, skip range, which will come into effect in the second one, and ASCII num, which I use all the time. We have a standard loop with the beginning and end of the input text. S5 is going to hold a check of which part of the input we are working on, whether the ranges or the fresh IDs. And we have our input loop, right? This is our set less than. We set S2 to 1 if S7 is less than S6, so if, you know, we've passed the end of the input. So if it's not equal to 0, then we branch to test num and we load OA into S3 in the branch delay slot, so it will be there even if we branch. If we don't branch, we load the byte out of the input. And if it's equal to OA, then we branch into test num anyway, but we do change what's in S3 in that branch delay slot to 2D. If it's equal to 2D, what's in the, which I believe 2D is the hyphen in ASCII, then we're branching to test num, right? And then we're loading OF in the branch delay slot, so we're making use of those branch delay slots. So if we haven't branched, then we're going to use OF to convert the character we just loaded into decimal, binary code decimal, and we store it into ASCII num with our standard way of loading the length. Adding 1 to it, storing the length, adding the length to the memory address, and then storing the byte in that memory address. Then we've got our loop, which goes through, which takes us back up here. Our increment, loop increment, takes us back up there. So if the next thing to see is if we go to test num here, we load the byte, we load the length of ASCII num first, and we check if that is 0. If it is 0, so this is most likely going to happen when we get to the blank line here, and on the input there's usually a blank line on the end. That just tends to happen, so often you hit that and you want to just handle that blank line as well. In that case we go to the 0 num handler, and we don't do anything there. That's my 0 num handler. Is a simple thing here, is that if S5 is equal to 0, then we're branching to the increment loop up here. And we're adding 1 to S5. So that changes the mode we're in, whether we're doing the ranges or we're doing the fresh IDs. It's going to change that. But if it's not equal to S5 is not equal to 0, so that would only occur for past the end of the fresh IDs, then we're going to fall through into the rest of this, which is collapse ranges and the gold section. So that's when we get to the gold part. So if that's not equal to 0, then we go into the convert ASCII, and then I clear the ASCII num once we're done with that. If that's equal to 0, if S5 is not equal to 0, then we branch to test freshness, this part down here. And when we're done with that, we're going to come back out and go to the increment loop. But if it is equal to 0, then we want to store it in the range list. Right, we want to store the value in here somewhere. So there's something I should be doing here. I'm not too sure. Let's see if we load. I think I just store them as a list of numbers, right? So I'll just say for this example here, right, because we've got this list here. So in memory, we've got what, 2, 4, 6, 8. I think I essentially just store them, and I don't know why I'm doing the multiply here. You see, this is a mistake, right? It looks like I'm doing a multiply where I should just do a shift. What an idiot I am. That in memory they're just going to be stored essentially as a list of doubles, I think. So you'd have 1, there'd be 3, 5, 10, 14, 16, 20, 12, 18. They'd just be stored as a list like that. And then I just pick, when I go through these like fresh tests and whatever, I just pick 2 at a time, right? I just pick up like, yep, these 2 is the start and the end, that there's the start and the end of that one, that there's the start and the end of that one, right? I just go with them as in pairs, essentially. Yeah, so look, I think what I'm doing here is dumb, and I should do a I don't think I'd be using it. See, what I should have down here is shift logical left, doesn't need to be a double, I don't think. It's to do I need to shift logical left I don't think so. Just a second, let me just check that, because of course I need to check the manual again. Where did I store my the instruction set? I believe it's not. I think it's just shift logical left. I don't need the I on the end of it. Shift logical left. Yeah. By SA. Yeah, I think it's just a value that goes in there. I probably got this down here somewhere actually. And we're actually using it. ASCII. Yep, there we go. We're fine. So where are we? Test num. Here we are. So I should have shift logical left, S2, S2. So I want to store in S2 again, and use like 3, I think. And that will multiply it by 8. This is what I should be doing. instead of using a multiplier in there. Anyway, so let's say we haven't branched out. I load range list into there. I load a double. So because I've got some very long numbers in my actual input, I think greater than 32-bit, I have to use doubles here. So this double here is the length of the array. I add 1 to the length of the array. I store it back in, and then I multiply it by 8 because it's going to be 8 bytes in length. Each one's going to be 8 bytes in length. And then I add that to the address, right? And then I store it and jump back to the increment loop, the loop increment, right? So yeah, I'm just storing them as doubles in this long array, and then I'll load them two at a time. So that's let's have a look at that convert ASCII as well. So we'll see here that I've fixed my convert ASCII here this time. I'm not using any multipliers. So I've got load an ASCII num, the length of it. If it's 0, then we just exit. It shouldn't be 0, but right, we shouldn't come to ASCII num if it's already got 0 in there. But it's okay. I add the length to the memory address, and that gives me the end of the input. Then I add 1 to the address, so that gets me the first value. So now, instead of going from the ones digit and working up back towards whatever the highest digit is, I'm going from the highest digit and working down to the ones digit. S4 is going to be the result. So we shift S4 left by 1, which is a multiply by 2. We store that temporarily into S3. Then we shift it left 2 more times, which multiplies it by 4, so a total of multiplied by 8. Then we add the multiple of 2 to the multiple of 8. Then we load that byte out of ASCII num. We add it to S4, which will be into the ones position. And we check if we have reached the end of ASCII num, the value that's in ASCII num. If we haven't, well, we add 1 to it regardless. If we haven't, then we branch back to the loop again, which will multiply it by 10 again, and then add that value into the ones position, essentially. So that does that, and then we'll return the value in S4, like set up here. Right, so that's better. It's not using multipliers because it's a power of 2, and so you can just easily shift. So once that's done, once we've got all those numbers in there, all the ranges done in there, we're going to be jumping to the test freshness. So where's our fresh test? Our fresh test is here. Back up a lot of values registers as well. Again, we load in this range list. I can see that I'm doing a dumb thing there, although, oh no, that's me just moving beyond the first one, I think. So I load the length. I do shift this one. I use a double. Don't need to use a double because it's a 32-bit value for addresses, but I used it anyway. I don't think it takes any more time. I think it's the same. So adding 8 gets me to the first value. It goes past that first double in range list, and that's the end of, well, that's how many bytes from, or how many bytes in length the range list is. Then I add that onto range list there to get the end of the array, where the last value in the array is. Then we go into this loop ranges, right? And So if we do this check to see if we're at the end of the list, right? If it's equal to 0, right? If we set, if that is, yeah, so if that is less than that, then this gets set to a 1. If it's equal to 0, so if S6 is not less than S7, then we branch, we exit out, we go to the fresh end. Otherwise, we load the value that's the value at, we do a load double, the value at S6, we add 8 to S6, then we load the next value into S1, so I've got the beginning and the end of the range. That was in memory that we had there, and we do this, we do a set less than, right? So if the value that's in, well, we set S2 to 1 if S4 is less than S0, right? S0 is the bottom of the range, so if S4 is less than S0, then it's not within the range, right? And that would, yeah, that would set to 1, and so if it's not equal to 0, then we go to ranges next, we try the next range that's in the list, and then we do the second check here, which this is going to set S2, it's in the branch delay slot, so this is going to get set regardless of whether we follow the branch or not, but it doesn't matter down here, we don't care about the result of S2, it just gets thrown away. So in this case here we set S2 if S1 is less than S4, right? So if the value that's in S1, the end of the range is less than the value that's in S4, then we, remember S4 is the value we got back from convert ASCII as well, right? It's this value that we got out of here, one of those fresh IDs. Anyway, yep, so that was set that to 1 if S1 is less than S4, so the top of the range is less than the value that I have in S4, and we load into S0 in the branch delay slot the address of silver result, and if we don't branch, then we load the value out of silver result, we add 1 to it, and we jump to fresh test end and store the value back into silver reds in the branch delay slot, right? So I mean, this is kind of quite, I think this is kind of nice here, is that we have that branch delay slot where things are going to get run regardless of whether we take the branches or not, but you can see that I don't have to use any no-ops here, right? So, you know, making use of those branch delay slots to do things is one of the things of MIPS, and it's kind of fun, just working around what you can put into there and not. So, yep. So if we found a value that updates silver is there, and then we exit out. If we don't find any values, we exit out, and we load all those values out of the stack again. So we go all the way through that list, and then once we get to the end of all these values that are in down here that we want to check for, we will eventually fall into this collapsed ranges part here, which is where we're going to have this gold res thing occur, or the gold result occur. So let's have a look at the collapsed ranges. I believe, there we go, collapsed ranges. Essentially what I'm going to do here is, let's go to the next part down here, shall we? Try, like, load this range I've got here, and then see if any of these ranges overlap it. None of them do in this case, so we go into the next one here, let's see if any of these ranges overlap it. That one there does not, but this one here does. So then I would add, well, I take the lowest of the range and make that the value that goes in here. Then I take the highest of these two and I'd update this one here, right? And then I would say this range here will ignore it. This will be the skip range, the skip list thing that I've got, right? We'll just go, right, we'll just ignore this range here from now on. And this one here will be now 10 to 18. And then what I want to do is go through it again, probably using this one here as my pointer is again, or maybe even go from the start again, and see if there's any that overlap. And you just keep doing that until you can find no more that overlap each other, and then you're done, sort of thing. So let's see if that's what I'm doing. So I back up all of these registers. I've even got a T0 in here this time. We've got this collapse setup. Range list, I load range lists beginning. I've got the length of it here. We move, right, I do -1 to it. Okay. Right, because they're in pairs, I don't want to go to the very last one. I want to go to the one before the last one, right? Because these are all in pairs and I want to load them in pairs. You don't want to go to the last one and then try and load one more afterwards. You want to go to this one here and then load one afterwards, and then you're at the end, sort of thing. T0 gets zeroed out. We load 1 into S1 there for whatever reason. Then I've got this outer ranges and a sort of check thing here. So we do this multiply by 8 into S2 from this S1. Where is S1? Right, 1. There's just a 1 there. Right, we start at position 1. Right, the first element in the array. Multiply that by 8, and then we add that to S2. Right, add that to S0. This memory address here, and store it in S2. We load the first value S6 and the second the beginning and the end, and we store that into S6 and S7, and then we jumped to this collapse inner part, right? And we're going to store, once we come back from collapse inner, we're going to store them back into the same positions, right? So we end up updating the same place. We add 2 to S1, which is this pointer thing here, and if S2 is not equal to S4, so this is the thing where I'm going to hit exactly that value that's in here, and I better hit it, or else it'll just go forever. So it's not the best idea, but there shouldn't be any reason why we miss it. And if we don't take this branch, and see, well, no, I do want to do this here instead of in the branch delay slot, because if I do the two afterwards, then it's a problem. If we don't take this branch, then we do a check on T0, and if T0 is equal to 0, then we go to we're finished. But if it's not equal to 0, then we go back to this setup, and we'll start from the very beginning again. So this is that thing where if we merge any ranges in this process, then we will, once we get to the end, we'll go back to the beginning to see if we can merge any more of them. And only going through all of them and finding no ranges to merge will result in the actual end of this process. So, and that's all that's there. So let's have a look at the collapse inner one. We back up a lot of registers again into the stack. We add 2 to S1. Remember, S1 was the pointer thing that we're doing over here. Where are we? Right, to carry us through there. So essentially, like if we're looking at this on the outer of the range, it'll add 2 to it, and we'll start here to do the same thing essentially, right? To keep the same, or have another loop that's going until the end of the ranges. Anyway, whatever. I have this feeling that perhaps the -1 in, or the minus that I did on there ends up so that we stay in here instead of, it doesn't matter. It works. I'm not gonna think about it too much. So we've got this the skip check here. First thing we do in this loop is that we're going to do a skip check. Where's my skip check? Here's our skip check. We load into this skip range. We load a the length of the skip range, right? If it's 0, then we're not. If we have no ranges in our list here, then don't bother. Otherwise, we multiply that by 2. I think this is just words because it's just memory addresses that I'm like, hey, skip this memory address, essentially. I multiply it by 2, and then we add it onto there. Yep. I think this is going a backwards one. We're going from the back of the list forwards. Anyway, so we load the value out of there. If it's equal to S1, yes, it must be. Is it memory addresses or is it values? Because it's S1, so it's before we. No, it's indexes. It's indexes we're using, I think. Yeah, because it's before we multiply it by 8. So it is indices that I'm saving, and it's the indice that will be the beginning of a range. Only that one there, which I'm saving into this this skip check. So yeah, we do that. That's the end of it, right? And so we're going to be counting backwards. But I do -2 here. So I might be saving both of them for, no, because I'm saving words, because the memory, wait, no. I'm saving words because there could be considerably long. Right, it could be more than, I don't know how many values there are, but there could be more than 255. And so it's like, well, need to have at least a word so I can store, not a word, a half word. Yeah. So these are half words that are in here. So I load up the half word, which is 2 bytes. I check if it's equal to S1. If it's not equal to S1, then we check the next one. We go to the next position in the loop until we get back to the end. If it is equal to S1, so if this index is in the skip list, then we'll set to V0 to 1, and we'll branch out to our skip check end. This makes sure that V0 is 0 if we fall out of this check, and then we return. So V0 holds whether it is we're skipping or not. 1 for skip, 0 for not. Right. So here we go. Like if it's not equal to 0, then we go to inner ranges next. So that means that we're skipping this index. Otherwise, we do multiply by 8. We add the memory address for the list to it, and we load out those 2 values, right? So say we're looking at this one here, then we're loading this here, we're loading these 2 values out into T6, T7, and now we do these merge ranges here. First thing be, so the easy thing, if any of them are equal, then we're merging them, right? So if we have none of these show an equal value, right? But if this was 10 and this one here was 10, then we're definitely merging these 2 together, right? If this one here was 10 and this one here was 10, we're definitely merging them together, right? So if any of them are equal, we're merging, right? So that's what's going on here. These just checking if any are equal, And then we've got this thing here checking for overlaps. We've only got two checks here for overlaps, I think. Oh no, we've got a third one here. So the first one here is we set if T6 is less than S6. Then we have to check to see if S7 is greater than T6, I believe. Right? That ends up well inside it. Otherwise, we do we set this if S6 is less than T7. So it's true if S6 is less than T7. Yeah. So I believe essentially T6 is less than, that is equal to 0. Right, so if T6 is less than T7, right, that would be 1, so would skip this branch, right? If T6 is if T6 is less than S6, and let's just get this straight, right? So let's say this one here is S6, and this one here is T6, right? If this value here is less than this one here, and this value here is less than this value here, then we're definitely merging them. Is sort of what's going on here. But I should really, well, and I've already taken care of if they're equal, right? If this value is equal to this value, right? So that takes care of those merges there, essentially. If we end up into this one here, then this value here was greater than this value here, and I only have to check if we set this is true if T6 is less than T7, if this value here is less than this value here, right? So if this one's greater than this and less than that, then we overlap, and that takes care of all of our overlapping checks. That's all the overlapping checks you have to do. So, yep, if we end up hitting here or down to here, right, we don't take this branch, we don't take this branch, then we're going to merge the ranges. I don't know why I have this jump when we could just fall straight into it. I probably had something else in here before, and then I removed it and didn't. Wait, that is the right one, isn't it? Merge ranges, yeah. And then didn't remove it, the jump at the end. Anyway, that was silly. So we end up falling down into this merge ranges, right? So I want to add into skip range, right? This address S1, I want to add that into skip range. I want to add one to T0, right? So there's a merge that's going on here. Then I've got if S0 is less than, oh wait, I set V0 if S0 is less than S6 is less than T6, right? If it's not equal to 0, if S6 is less than T0, then we branch to this one here. Otherwise, I'm going to move the value that's in T6 into S6. Right, so that's going to end up the larger, right? It will end up the larger value. So say I'm merging these two ones here together. No, wait. No, it will end up the smaller value, sorry. it'll end up with a smaller value, I believe. So it sets if that, yeah, so if S6 is less than T6, then we branch. If it's not less than T6 or it's equal, then we move the value from T6 into S6. So we'll end up with a smaller value, right? Let's say we're merging these two here together. We're looking on this one here, and this was the outer, this was the inner. It will push this value here into here. Go to the smaller one first. And then we go for the high range, the top of the range, and we do sort of the same thing. We set that to true if S7 is less than T7. If it's equal to 0, so S7 is greater than or equal to T7, we skip that and we branch down to here. Otherwise, we move T7 into S7. So we end up with the larger value in the top part. And so we've merged those ranges together. And then we just keep going. Right, we fall down into the ranges next. So we want to go check as many of them as we can on this round, round through the list. And that's done. We've finished on the collapse inner part. Alright. So that will just keep looping through the ranges until it's compressed them, collapsed them all as much as it can, merged them all as much as it can. And at which point we'll return back here out of this collapse ranges. We'll load in the gold result here and load the value out of it. Range list, right? We load the length of it. Right, subtract 1 from that and add 1 to S1. So the same setup that I had before. We loop through the fresh IDs. We do our skip check. Right, we're doing the same skip check. If V0 comes back as a 1, then we're skipping. Going down there. We multiply by 8, this indice by 8, and then add the memory address of range list to it. If we're not skipping it, we load the two values, the beginning and the end of the range. We subtract the beginning from the end and add 1, and then we add that into S5, which is our result for gold. And we're using our double adds here because big. And then I'm storing it back every time, which is kind of dumb. I should really put this like here. Although, no, actually, no, I'm going to leave it there because this could take a couple of frames. I don't know how long this takes to do. It probably wouldn't take. It'd probably complete in less than a frame, but by updating it every time, it does mean that if there's a frame draw, a VSync, it will display the present result. And then we continue through the loop until we loop through all the IDs, adding them all to the result of the gold. Okay. And that is all of the code. Let's bring up the emulator. Here we are, day 5. Unpause that and let's run it. And there is our result. You can see the result down here on the browser for the gold part. 332.067203034.711. And for part 1, make sure we can see that up a little bit more, 773. So that's the largest result we've got so far. Anyway, so you can see it is relatively fast, and yeah, I'm fairly happy with it. I'm at least happy that I fixed the convert ASCII that I'm doing there. But yeah, I think things start to get a little bit more difficult from here on. Is it day 6 that gets harder? Can't remember. Anyway, so that is day 5 done. I know I mentioned last time that I was planning to do a video about my graphics, how I was doing graphics on the PS2. Since then, I tried it and I wasn't very happy with the result of that video. And I've also worked out a bit more of how to do CLUTs that I want to experiment on, how to do the textures and CLUTs, which is a better way of doing the textures than I'm doing. So I want to investigate that a bit more, maybe play around a bit more, and then I'll come back and eventually do that video. But until next time, will be day 6, and I hope to see you in that day 6 video. Until then.